Hey everybody, this is Mr. Russell. I want to congratulate you on clicking on the right link for your first lesson in Advanced Algebra and Trig. Now this video is the first out of two that you need to see today. So if you're in 8A, this should either be August 9th or August 10th that you'll be working on this material. And it's always good to look at it beforehand, but at the latest, you should need to be looking at this on August 9th or 10th. Let's kind of just get a feel for what we're going to be doing today. So right in this particular video, we're going to be reviewing the real number system. A lot of that stuff is stuff I'm sure you've had, in Algebra 1, maybe even pre-algebra back in middle school, and maybe again in Algebra 2, but it's something that we have to be really solid on as we move on in this class. Because in this class, the stuff that we're going to be working on in this first unit, the prerequisite unit, is just going to be so kind of all over the place. It's going to show up in so many different places that we don't really have time to go back and focus on stuff like square roots and real numbers and all this kind of just fundamental stuff that you're just going to need to know really well as we move on to functions and complex numbers and more functions and functions and functions and functions and maybe some trig. But anyway, let's go ahead and get started on our real number lesson today. Okay, so first thing, there are different types of real numbers, and there's different groups that we categorize them in. So let's go ahead and look at the first one. Okay, so these are called the natural numbers, and they're basically the kind of the first numbers you probably learned about, and they're also just think of them as like the counting numbers. So 1, 2, 3, 4, 5 goes all the way up. Any number, as long as it's positive and not a decimal or a fraction or something like that, we can classify that as a natural number. Now, if you add 0 to the list, 0 is not a natural number. It's what's considered a whole number. So this brings us to our first kind of level, our first two levels of numbers. It's really hard to be a natural number, okay? Because if you think about all the different kinds of numbers there's decimals, there's numbers that are square roots, there's fractions, there's negative numbers. The only numbers that can belong to this natural number group is these normal kind of counting numbers. So numbers like if you think about money, like the numbers that money can be. Right, so just kind of our normal numbers that kindergartners learn about. Okay, so our next group, this, as you can see, we're kind of adding more numbers. We're adding more things to what can be in this group. So integers are natural numbers and 0 together with their negative kind of counterparts. So integers includes all the negative whole numbers. Okay, so 0 is also an integer. So if you see the number 2, let's kind of go back. Is 2 an integer? Yes, it's part of the integer group. If we go back, it's also a whole number, and it's also a natural number. So these numbers are actually the ones that you learn about, the ones that you're the most comfortable with, are kind of the most special because they're in the most specific nitpicky group. It's really hard to be a natural number. If we look back to integers, that adds a whole new list. And again, these numbers are pretty small, but they go on to what's called negative infinity over here and positive infinity over there. It's just a never-ending list of numbers. Okay, now we move on to rational numbers. It's really just any number that can be expressed as a fraction. This down here, don't be afraid if it's all just because it's all letters. But what this means is a rational number, R, so R would be an example of rational number, is a number that's an integer. So let's say like, I don't know, what's a good integer number? Let's say like 2. Let's pretend n was 2. And then n is any other integer. So I could say like 1. Okay, so that's an example of that would be an example of a rational number. Another example of a rational number would be something like negative 4. Negative 4 would be an integer over 3. That's horribly ugly, but I'm writing with a mouse. Okay. One thing though, you can never have the denominator, the bottom number of a rational number, be 0, because it, let's talk about that. So if I have 2 over 0, why is that not okay? Why did I zoom in? Let me back up. Okay, so if I have 2 over 0, okay, what that means is, what I'm saying is 0 times something has to be 2, right? And that's not possible. There's nothing that can do that. So that's why you can never divide by 0. So just remember that. That's going to show up a lot later, especially on our rational expressions unit. You can, as long as these are integers and not 0, the bottom's not 0, that's fine. Okay, so let's erase that. So 0 over 2 is okay. 2 over 0 is not okay. Right? That's okay because the numerator is 0. That's not okay because the denominator is 0. Okay, so just keep that in mind. Alright, so these are all examples, different examples of rational numbers. So like integer, 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 and nothing on the bottom. 2, 7, 1, 100, none of those are 0. Okay, so if we think about, let's look at this one real quick. This number is actually, what is the most specific way you could describe this number? Take a second to think about that. Would it be an integer? Well, yes, because remember, integers are all the positive whole numbers and all the negative whole numbers, and 0. Would it be a whole number? Yes. Would it? It would be a natural number. You could count to that number if you were, in kindergarten. Eventually, I guess, like in the spring. But anyway, okay. Just remember this, and just keep that in mind. As long as the denominator is not 0, you're good. You can be a rational number. Okay, now here's a different set of numbers. These are really kind of probably the most annoying numbers to deal with. They are not. They're very unlike all the other numbers that we've looked at. Basically, because if you are an irrational number, that means that you can't be any of the previous numbers that we talked about. And this will make more sense with this picture that we're going to see in a minute. But think of irrational as like a crazy person. Like they can't be reasoned with. They don't follow any patterns. Like irrational, those irrational numbers are going to kind of be like that. The way you know if something's irrational is, first off, if it's in a square root, that's a pretty good sign. Okay, square roots kind of give you really, really hard to numbers that are hard to deal with that are not rational. So if you type these in a calculator, for example, like square root of 3, square root of 5, that is the cube root of 2. You all have heard of that number, pi. Looks terrible. That's 3 over pi squared. If you all type these in a calculator or on your phone, you're going to get something that is something that's just doesn't follow any patterns. The square root of 3, I'm not using a calculator, but it's probably going to be like 1.6733. Like it's going to be numbers that don't repeat and don't stop. Okay, so irrational numbers are, if you notice, they all have either square roots or these famous numbers like pi. Pi is a number that just doesn't repeat or have any patterns. Okay. So we've looked at basically all the real numbers that we're going to encounter in this class. And just as a little side note, so from now on in this class, in the book, anything we deal with, when we mean real number, if we say number and we don't say anything else in front of it, like imaginary, we'll learn about that later. We mean real. If you just say number, we're gonna take it that you mean a real number. So a number that falls into one of those groups that we've looked at. Okay, so again, real numbers are going to have decimal representation. So this is typically the reason we're going over this is because this is what your calculator will show. So I just made up a number here. If the number is rational, it's decimal. The numbers after the decimal are either going to stop. That means terminate, right? Terminate means to stop, or it's going to repeat itself. So even though this would go on forever, there's an obvious pattern. It goes 4, 5, 4, 5 over and over and over again. So this is called a terminating decimal, and this is a repeating decimal if I wrote numbers forever. All right, so they're both rational because they follow a pattern. This one stops, and this one follows a pattern, so they're both rational. Okay, these would be examples of irrational decimals. So the numbers after the decimal are not repeating. There's no pattern here. It just keeps going. This is pi. The reason they have, I don't know if you've ever heard of them, but they have those like memorizing pi contests where you like win money for memorizing like thousands and thousands and thousands of digits of pi. The reason why is because, well, one, I don't know why people get rewarded for that, but it's pretty hard to do. You just have to memorize it. There's no pattern. So you'd have to look at a giant list of numbers to be able to do that. Right? So remember, rational, that means think of rational as like a rational person. Like they can be dealt with, they follow patterns. So like these numbers, irrational numbers are all over the place. They just go crazy and they don't stop. Okay, so this is particularly important with irrational numbers, but we have to be clear about when we say something is equal to or approximate. All right, so if you see this little wavy equal sign, that means pi. What this says is pi is approximately or about 3.1415925. Right, but that's not what most people say pi is. Most people, when they say pi, this is the number they think in their head. They don't think really past 3.14, because usually that's good enough. Usually, if you're doing a word problem or something, or you're measuring something that involves pi, this is good enough to get you pretty close to the right answer. Okay, it means this squiggly line means approximately equal to, but it's important to remember the more decimal places you keep, the better your approximation is going to be. So let's say in video games like Madden or Call of Duty or whatever, where you have to have really, really, really good control of your character and they're supposed to move really realistically. The game would be taking a bunch of measurements of stuff, like how fast something's going or how big something is. If you want a better approximation, if you want things to kind of be more precise, you're going to need to have more digits and not cover these up, right? So just keep that in mind. For most of the time, for us, we're not going to need to go too far with the decimals. Maybe to the thousandth place at the most. But just remember, this is approximate, and the farther out you go, the better your approximation will be, the closer it'll be. All right, so let's move on. Okay, so again, this is just kind of showing. This is just a notation with decimals that shows you that something goes on forever. So 1/2 would be 0.5. That's actually, if you type that in your calculator, it's 0.5, and it doesn't have any zeros because you can just add as many zeros to the end of a terminating decimal as you want. But something like 2/3, that's 6, just never ends. So this is just a shorter way to write it. Right? It just means it keeps going. Okay, now, you might want to pause the video right here in a little bit, or right now, and take a picture of this, or just stare at it for a little while, do whatever you got to do, but this is a really concise way to summarize what we went over. This is called, I guess, it's not set notation, but it's a visual representation of all the different sets or groups of numbers we looked at. So again, something like a natural number, see how it's in this circle right here? If it's in this circle, right, like so the number 7, any other circle that kind of is swallowing this one up, it also belongs to that group too. It's also part of that group as well. So like 7 is a whole number. 7 is an integer. 7 is rational. 7 is real. Would 7 be irrational? No, it wouldn't, because this circle right here is not does not envelop or does not engulf this one. Okay, and notice, see how the irrational numbers are kind of separated from this really big group that includes most of the numbers that we're familiar with. Because remember, irrational numbers, if they're not rational, rational is about as far out as you can go with the real numbers. And none of these are going to be able to fit in here. They're not going to follow these rules. Okay. So if I said, if you're taking a test or a quiz or something, and I said, what is the most specific specific set that -3 would belong to? You say, oh, well, that's an integer. If I said, hey, is -3 a rational number? Would that be true or false? It'd be true, because -3 is also rational, but it's also an integer. Okay? So just remember this picture right here is going to be really, really kind of a helpful way to summarize all the stuff we just talked about. Okay, so let's take this little, this is going to be our first little kind of learning check. Take a second to look at these numbers right here, and look at the question. What is the most specific way to classify these numbers? Go ahead and pause the video and take a minute to answer these. Okay, so let's go ahead and take a look. A, that should be a natural number, right? That's the most specific way. So if it's just kind of a regular counting number. It would take a while to count up to it, but it's a positive number that would just be in that list of natural numbers. B is rational because it's got an integer on top, -6. It's got an integer on the bottom, 5. It doesn't have 0 on the bottom, so it's rational. This is an integer because -6 divided by 3 would be -2. Okay, so yes, it is rational, but that's not the most specific way to describe it. -6 divided by 3, you could go one step further, actually do the division, and that would be -2. So that's an integer. Okay, natural. This one is a very tricky way to write a natural number. So it looks like it does have a square root. And you don't want to train yourself to say, oh, it's got a square root, it's got to be irrational. Take a minute to see if it's, like, either use a calculator or see if you probably should know this one. Check it on a calculator and see if it gives you what kind of number it gives you. So if you put this in a calculator, it's just going to say 5, which is a natural number, just like this one. So these two guys are in the same group, right? They're both natural numbers. Okay, irrational. So if you do square root of 3, it's going to give you a decimal number that is just going to go on forever. It doesn't terminate, doesn't end anywhere, and it also doesn't repeat itself. These are just kind of, don't really follow any pattern. They're just kind of random as to what the next number will be. Okay, good. So we've done the first part of our first lesson today. So now we're going to move on to these things called intervals. All right. So this is going to be something that I know you've seen before. But our book kind of has a specific way it wants us to think about, and it wants us to write these out. Okay, so to kind of put this in context, let me go ahead and draw something on the number line. I'm going to pick green, or maybe, I don't know, I guess I'll do green. All right, so where'd it go? There it is. Okay, so I'm going to make a simple little picture right here. All right, so I just drew 2 dots. Okay, so we can think of this as like a group of numbers. So we've got this green group of numbers. All right, now here's the Algebra 1 way that you probably learned how to represent this. Okay, so the Algebra 1 way is you say, okay, well, there's an x because we don't know which number you'd pick. You can be any of these numbers that are inside of this green line. So we'd say that x is greater than 1 and less than 3. All right. Now it's actually not right yet, because see how these dots right here are colored in? What that means is that you can also be equal to the numbers that are on the closed dots. So that means I could be equal to 1 and I could be equal to 3 because they're closed in. Okay. So this is the Algebra 1 way of writing it. The way our book is going to do it after this lesson is not this way. It's actually a shorter way where you just kind of have to know a little bit about what symbol means what. So the Advanced Algebra way is shorter, and it's also it just kind of looks cleaner. So let's go ahead and look at the advanced way to represent an interval. Okay, so I'm going to look at the same group. Okay, same picture. But what I'm going to do is say, okay, well, I'm going to draw for where the group starts, our green group. It starts at the number 1, and what I've drawn is a square bracket. All right, square bracket means you are allowed to actually be on that endpoint. You're allowed to be on the number 1. Okay, so you could equal 1. And then all these numbers that are in between, I don't want to write all those numbers, so I'm going to do a little comma. That comma says all the numbers, including 1, all the way up to 3. Okay, and 3 is also closed, so I'm going to do another closed bracket. So this is what the advanced algebra way of of representing this interval. Okay, so this is the old algebra 1 way that's not very good. This is the advanced algebra way that's, as you can see, it's easier to write and it looks cleaner, right? Okay, these brackets make all the difference in the world. These brackets say, hey, if it's what's called a square bracket or a closed bracket, that means you are allowed to actually step on 1. So 1's in the group. Okay, he's allowed to be in the group. So is the number 1.5. So is the number 1.1. So is the number 2. So is any number that's in between here. As long as you're not bigger than 3. It's okay if 3's in the group, but 3.001 cannot be in the group, according to this. Okay? Good. All right, so now what we're going to do is look at an open interval. Okay, so an open interval, I'm just going to pick a different color, and I'm going to do some different numbers. All right, so let's say I want to make another club. All right, so I'm going to pick red, I guess. All right, so I'm going to do this. I'm going to have a little dot, little circle right there, and then I'm going to circle the number 1. Okay, and then I'm going to color it in. All right, so this is it's in a different place, and again, the endpoints are kind of what the most important parts of the whole thing. So in this club, because there's an open circle right here, that means that this number that it ends on is not allowed to be in the group. So -3 cannot be in the group. You can get really close to -3, like -2.9 is in the group, -2.99 is in the group, -2.99999 would also be in the group, but -3 would not be allowed to be in the group. All right, and the way we represent that, I'm not going to do the algebra 1 way. We're just going to start doing our advanced algebra way of doing it. The way we represent that, instead of a straight bracket, we have to do what's called a just, I guess, a parentheses or a curly bracket. Okay, so just draw one of these, and it looks like, all right, we start on -3. So this curly bracket says, hey, -3 is an endpoint, but you can't actually get to -3. Comma, remember comma says, okay, comma is all the numbers that are in between, so that comma represents all these numbers. And then it looks like we have another endpoint at the number 1. And the number 1 is open, has an open circle, so that will be another curly bracket. Okay, so the number 0.99999 is allowed to be in the group, right, because it's not 1. The number 0.9999999 would also be in the group, but the number 1 is not allowed to be in the group. Okay, so it may seem kind of picky. It could be pretty, like, seems kind of pointless to do this, but it becomes really, again, a lot of this stuff's going to become really important when we actually start trying to see what happens when you divide by 0 and doing rational expressions and graphing and figuring out asymptotes. So the distinction between a closed bracket and an open bracket is really subtle, but it's really kind of the key to a lot of the stuff we'll be doing later on in the year. All right, so let's look at one more thing. Let's go ahead and look at a mixed interval. Okay, so what I'm going to do is I'm going to draw it on here, and then I'm going to pause, or you should pause the video and kind of test yourself and see how it would look. Okay, so I'm going to go ahead and go here. You get, I don't know, this color, what is this, teal, turquoise, I don't know. Alright, so I'm going to draw this right here. That's clearly open. This is clearly closed. Okay, so go ahead and pause the video and see if you can predict what I'm going to have to write to represent this interval right here. Okay, go ahead and pause the video while I color this in. Okay, good. Alright, so here's what we do. So it looks like -4 is going to be an important number. So there's -4. 5 will also be an important number, because it's on the other side. Got to do a comma for all the numbers that are in between. Okay, that's an open circle, so that means you can't actually get to -4, so you've got to go curly. 5, it looks like, is closed. That's a dot, so that's going to be a closed bracket. So if you wrote that down, good job. All right, let's do one more, and then we'll be done with this first part of the lesson. All right, so I'm going to pick pink. All right, so it went away. Let me find pink again. All right, there it is. Okay, so I'm just going to, I don't know, I'm going to do this and this and all the numbers in between. Okay, so let's look at this real fast. So -4. What the? Alright, -4. That's a closed dot. So I'm going to have a square bracket, comma, for all the numbers in between, and then -1. And it looks like that's an open circle. That means you can't. -1's not in the club. He's in the club. She's in the club. She's in the club. She's in the club. All these numbers are in the club. Once you get to -1, you can get very close to -1, but you can't actually be -1 and be in the club. So that means a curly bracket. Okay? All right, good. So let's go ahead and talk about what your assignment's going to be. All right, so again, the SIG is going to be the center of the class, and your formative assignment is linked underneath that column. So make sure you check either under August 9th or 10th, if you're A-Day or B-Day, and follow the instructions from our first class on how to turn this in. So the August 5th, August 8th, kind of intro to the class, we went over how to turn it in. So if you haven't seen that, how about you go back and watch that video and review those notes. All right, till next time. See ya.